Assalamu alaikum wa rahmatullahi wa barakatuh. Today is the second lecture talk about assembly. I have the files, all part files, and I want to make the assembly. So I have to go to new at the beginning. Surely will not select part file because we finished the parts. We'll go to assembly. It depends on unit you have or you used before, English or metric in the part files. If the part files in metric, surely I have to select metric for the assembly. In the assembly, as you see, we have many file format or user interfaces, something for the mold design, something for standard assembly, for weldment. I will use or choose the standard one, then select create. Now, as I told you, I have all of the parts. So I will place the first part. Again, I am the designer and I prepared all the part files. This is the case always. So you have all of informations needed, all of the file or the files needed. So I will start from the arbor frame, open, then I will select OK. This is my first part in the assembly. So now we should go to constraint. As example, we can use insert, we can use axis to axis, face to face, anything you can use, no problem. So say axis to axis, apply, cancel. The arm will go up and down. I can use the insert better, but I want to show you how we can control the movement. Now the arm should not go up and down while rotate the shaft. So we can go to the arm and see what we have. We have this worker plane available. We can use it, no problem. I can use the origin also. So let me select visibility on. And let me go to the shaft, pinion shaft also. We have this worker plane, we have this worker plane, we have the origin. Say the right, okay, visibility on. We can mate these two worker planes together, so to keep the arm rotating with the shaft and connected. So constraint mate this worker plane with this worker plane, apply. We have a conflict, we can do that. Let me use the flush instead. I want to make this plane parallel to this plane with offset distance 0. Okay, done, no problem. We can control the distance, change it from 0 to another distance, no problem. Now we have here how we physically can connect the arm with the shaft. We need the bolt here, so thumbnail screw. So I will go to place and choose the thumb screw like this. Okay, now we want to the best way, guys, we have first to prepare the thumb screw like this. Second step, we can constraint axis to axis like this, apply, but still it moves like this. Now when the screw touch the cylinder, it will become tangent, so I will do the same. I will move it like this, rotate like this to prepare it. Then I will go to constraint. From constraint we have tangent constraint. I want this surface to be tangent with this cylinder, apply, cancel. This is the best way. The last thing, for the screw and the shaft should move together or rotate together. Let me go to the thumb screw and see what type of worker plane we can use. We have this worker plane and the thumb screw. We can use the origin, YZ plane. We can use XZ plane. I think XZ plane can be used. Okay, now I just want to constrain mate the thumb screw worker plane with the shaft worker plane, apply with 0 offset. Now they can move together, as you see. Now for the ram, we have two cabs. We can go to place and bring the cab, this cab twice. We need one here, we need one here. The shortest way we can go to constraint and use insert. I want to insert this cap so that this circle mate with this circle with offset, say that -10 as example. Again, we should know exactly what is the distance. Same thing for this one. I want to insert so that this circle and axis mate with this circle and axis. Oh, I forgot the constraint offset distance. I will go to hand cap number 2 to the insert, double click. The distance should be -10. No problem, you can edit any time. Now I see they are moving or rotate together. The last thing for the shaft, guys, from the back we have to place the collar. So I will place and go and search for collar. Okay, open it, place it here. We can use insert axis to axis, face to face, but I think we can use insert directly. I want to insert so that this circle and axis mate with this circle and axis with distance, say that -5. Distance not enough. Again, this is design. Quantity should be known, say -25. What I did this for handle cap, sorry, this should be -10 as before. This color should be -25. -25 too much, says that -15. Again, we should know exact distance. It's okay for me, -15. As you see from the left side view, it's okay. The last thing for the collar, it should rotate with the shaft. As you see, when the shaft rotates, the collar should rotate with it. We can see the hole rotating like this. So let me go to the collar and select one of the planes. Say that I want XZ plane, visibility on. I want to mate work plane for the shaft with work plane for the, constraint the shaft and mate the shaft work plane and the collar work plane together with offset 0. Now see what will happen if you rotate. See, the hole moves or rotates. That means the collar connected to the shaft correctly. Now for the collar, the last thing here also, we have to place or to bring one of the bolts. So I know that this bolt is this one. Let me bring it here. Again, same story, guys. We can use insert or axis to axis, tangent. I think better axis to axis and tangent. So mate axis to axis like this. Apply. It's opposite. Cancel. Undo. Let me prepare it bifurcate it like this first. Okay, and then go again, constraint, axis to axis, apply. We can choose the other option, just wait. Again, constraint, axis to axis. Okay, use the align this time. Yes. Now you can move it like this. Now we want to free rotate the screw or the bolt, and then constraint using tangent constraint. I want this surface to be tangent to this surface because physically this is the actual thing. Now everything is okay. Also we can keep the bolt not rotated, but no need now. Next we have to place these 4 holes, screws, and here also. So I will go to place again. These we need 4. 1, 2, 3, 4. Again, the best thing, insert, I think. So I will make insert. I want to insert this screw so that this circle and axis mate with this circle and axis with, say that -30 offset. Again, we should know the exact distance. -30 too much. So let me go to the hexagon head. This one, go to the insert, make it -15. Let me check -15. It's okay. -15, say -20. -20, it's good. Again, we should know these informations before. Again, constraint, same story, insert with distance minus 20. I want to mate this circle and axis to this circle and axis with minus 20 offset distance. Again, minus 20 again. This one here, apply again, minus 20. The last one, this one here, apply. And we have here two screws also. We can place them again. Go to place and select I think this one, 1, 2. Prepare them first by free rotate, and again we can use insert, constraint, insert. I want to insert so that this circle and axis mate with this circle. So I think the offset distance say minus 10. I don't know, minus 15 maybe, or 10. Again, we should know the quantity exactly. So minus 15, good. Again, minus 15, insert. This one, no, I have to free rotate to prepare it first, then go to constraint again, the offset distance minus 15, which is in the insert, this one here, apply, cancel. Now it's okay. The last thing, we have to add the plate and the pen for the plate. So let me place, sorry, again, place. You want to place the table plate and the groove pen. This is the table plate and this is the groove pen or groove pen. Okay. Constraint, mate this surface with this surface, and again this axis, constraint, or let's move it out, constraint, axis to axis. So I will constrain this axis to this axis, apply. We have conflict because I didn't select the proper option. Again, axis to the axis, aligned. Okay, now it's okay. The last thing, this if it can rotate, okay, but if you want to fix it, we can go to table, check the origin. As example, you can select XZ plane, make it visible. You can go to constraint, make flush or angle, better maybe. Make an angle, direct angle. I want the angle between this work plane and this surface to be 0 at initially, and that's it. And also we can constrain, we can, I think, insert better. I want to insert this pin so that this circle and axis mate with this circle and axis. Apply. How much the distance or the offset? We should go to groove pin again, insert again, cancel this one, insert again. The distance, say that minus 20. It's good. Now the assembly, it's ready. No need to add any more constraints. But once you finish the assembly and you want to demonstrate the motion and show the others how motion will be, you can add one constraint. I think we can add an angle, because when you rotate the handle or the arm, the angle of the arm with some reference will be changed, or the distance of the ram will be changed. I think distance is better, but before that, let me go to this work plane, make it invisible. This work plane, make it invisible. This work plane, make it invisible. Oh, I'm sorry. I want this work plane, not the part, invisible. Oh my god, I'm sorry. Again, undo. With this work plane, visibility off. Okay. Visibility off. I can do it from here. So let me select it from the model browser. Let me go to the shaft, pinion shaft, go to the origin, the right, visibility off. This one done. Okay, for this one we can select, I think, right click, visibility off. No, let me go to table plate, the origin, again same story, visibility off. Now as I told you, want to add, let me go to front view, show you the distance changing. we want to add another constraint to diminish the motion. When the RAM go up and down, the distance between this surface and this surface change, or this surface and this surface change. It's up to you. You can use both of them, sorry, one of them, any one of them. So let me select one of them. So I will constrain mate or flush, it's up to you. Let me make mate at the beginning, mate. This surface should be mated with this surface at the beginning with offset 0, no problem. Okay, where is this one? Let me go to the table plate. This is our mate. Just right click and drive it. At the beginning distance is 0. Say that from 0 to 80 again. You should know what's the maximum and the minimum. Move, very good. Now let me select another view to show you the motion. Let me go to the home and then rotate it like this. Or you can select from one of these angles, it's up to you. Make zoom in, zoom out. And now again go back and then run. One of the benefits of Inventor that you can record this motion. Just click here to record and then select the file where you want to place. Say that I wanted to place it in this location, and then set some properties for the movie, and then OK, and then record your motion like this. Now while it's moving, it records the movement, and you can then share the video with others. So just once you finish, you can go to the file and open the video.